everyone, this is your Ragvi Deva. I hope all are doing good. Today we are going to see the topic is about Mos Transistor Principle under the syllabus of VLSI and chip design. This is the very basic introduction part of topic as Mos Transistor. As you are familiar with that, as you're so many of places we cross across with that the term of transistor. So transistor is nothing but you just split the term tran plus sister. You just split the term. It's a combination of tran plus sister. Sister is nothing but the part of resistor term. Actually, it represents the trans plus sister, meaning is that transform the resistance from high to low, which means here the resistor value is too low. Indirectly, it represents the high current value, right? So actually, it represents it's a current conducting device which indirectly give the meaning of transform the resistance from high to low. Okay, actually here we are preferring the transistor. What is the main purpose means to carry the informations. Here it will be carry the information in the form of current. Especially we have so many classification of transistor, but especially here we use MOSFET in our VLSI integration part. Why? Because means MOSFET which provides low leakage plus high thermal stability and so many places there, but uh, emphasis advantage is that low leakage and high thermal stability. So because of that we are preferring that Mos transistor. Here we show the cross sectional view of Mos transistor. Actually MOSFET FET is a voltage control device. Here we are using MOSFET metal oxide semiconductor 3-layer terminal. uh, Metal here we are designed with gate terminal, then oxide insulating layer, then last part of substrate as a semiconductor layer. So here you see the base region as a semiconductor we are preferring to take as a substrate, and then in this substrates we have to develop the source part and drain part by doing the process of doping conditions. If suppose we are considering NMOS transistor means we have to suppose we are considering NMOS transistor means the majority carriers is electrons. So what type of transistor we can able to design? NPN transistor. So the center part P, right, that to be as manufactured as your substrate. Suppose here we are considering NMOS transistor means the substrate should be P type of substrate, and the remaining two term n p n, first part as n, last part as n, right? So first part is made for source region, last part is made for drain region. So here the substrate, in the entire substrates we have to develop the source region and drain regions. So by doing the process of doping, if you want to develop the p type of substrate we have to add the doping material as boron. If we do that doping process, we can obtain the N type of material. Then above the layer, we have to develop the oxide. So oxide which acts as a insulating layer. So it is made up of silicon dioxide. And then above that, we develop the metal layer, that is to be a gate region. It is made up of polysilicon material. So all over we have three terminals: metal, oxide, semiconductor. This is the structure they defined for MOSFET transistor. So it has three terminals as we know, right? Gate, source and drain. So in this, gate acts as the input terminal, source as a mediator, drain as the output terminal. But in we have one more terminal as fourth terminal as substrate. It is also called as body or bulk, right? So this is the cross-sectional view of about Mos transistor design. As I already said that it is a voltage control device. So voltage control device, what it here they are trying to convey means we are providing our input in terms of voltage to the gate terminal. Gate terminal has the control capability to change the conductivity of the current flow between the source to drain region, because here input as in the form of voltage, output is in the form of current. If you want to do any changes in the current terminal, we have to adjust at the part of input terminal in terms of voltage. So that's why it gets the name of voltage control device. Okay, I think I can clearly tell you, explain you as about voltage control device, which is nothing but it has the ability to change the conductivity of current flow between source to drain region. Yes, I think you may get understood what I try to convey. So basically it has four terminals and it is made up of three layer terminal. First as metal gate electrode layer, second is insulating oxide layer, third is pure n-type substrate. As I told, what is the working behind that? Mass transistor. And we have two types of MOSFETs, one is n MOSFETs and p MOSFET transistor. As I told as early, NMOS transistor means the majority carrier is electron, so we have to design NPN transistor. So PMOS transistor means the majority carrier is holes, so we have to design PNPN transistor. So here we use the symbol representation uh, for NMOS and PMOS, gate drain source. PMOS we have to add a bubble, NMOS we never add a bubble. And then this is the cross sectional view. So cross sectional view, if we consider NMOS means the substrate to be a p-type substrate, source and drain region as n-type substrate. So from source to you move on to sources, substrate, drain. Source as n-type, substrate as p-type, drain as n-type. Again you have to develop silicon dioxide layer and gate. If take a cross sectional view of PMOS means entirely opposite to that of NMOS. So the substrate to be N type, source and drain to be a P type material, then you have to develop the oxide layer and metal layer. This is a cross sectional view, because why we have to show the cross sectional view means, so internal working flow, how it will be get processed, that is to be interior study of that transistor principles. So we have to familiar about that cross sectional view, because hereafter moreover most of the places we use this cross sectional view. Then it has two types of operating mode, one as enhancement mode and one as depletion mode. So actually enhancement mode we can represent the NMOS and PMOS as usual, symbol representations. Well, during this condition enhancement mode, the transistors normally off conditions, that is it to be off at VGS equal to 0 conditions, which means we are providing our input between the gate to source terminal. So that represents the gate to source terminal voltage. Here they are representing. Initially we never apply any supply, means the transistor to be in a off mode. If suppose we want to on the device means we have to apply the gate to source terminal voltage part. This is general. General, if you want to switch on the fan means we have to give a supply. Else, if you no need, uh, if you know if don't want to run the fan means we have to off the switch. So what is the procedure we done it for that switch on and off? The same conditions here they explain for the enhancement mode. So depletion mode is entirely opposite. So this is the symbol representation of the depletion mode. What is the change between difference between the enhancement and depletion mode means, here we have shade. We are using the shade in depletion mode, symbol representations, and normally it will be in on mode at 0 supply voltage. Suppose if you want to of the device means we have to apply the gate to source voltage. That is the reverse conditions of that enhancement mode. So we want to initial period of time, we use both the condition depletion and enhancement during their operations, but later we developed first period of time we started to use the NMAS, then PMAS, then combination of PMAS and NMAS. So that combinations, complementary metal oxide semiconductor, that type of transistors only nowadays we are using in our VLSI culture. So earlier days we use depletion mode, but later we move on to that enhancement mode. So these are the two types of modes we are using in that VLSI culture. So these are the applications we are using the MOSFET transistor. So basically it is used in our calculators and memories, logic gates, analog type of switches, amplifiers, especially digital ICs like microprocessors. So these are the applications we are using, but it has so many applications in and around the world. I hope all are understood these concepts. Thank you. If like this video, please like, share and subscribe. Thank you.